Hi, in today's video we will try to learn Bayes' theorem, which is based on Bayes' rule. So let us start with Bayes' rule. Bayes' rule states that probability of event A given event B is equal to probability of event B given A into probability of A divided by probability of B. Bayes' rule states same formula but with two different components instead of A and B event. Same formula is represented with hypothesis and evidence. Now, hypothesis is nothing but a kind of deduction or consideration that we have drawn from a training data. Now, here training data is data which is used as an evidences. Whatever the deductions or outcomes of training data is there, our test data will be classified according to the hypotheses that are made from training data. So observations or training data are considered as evidences, which is represented by capital E. So rewriting same Bayes theorem, instead of event A and event B, we will write probability of hypothesis being true given that evidence is received is given as probability of evidence given hypothesis into probability of hypothesis divided by probability of evidences. We will try to understand this particular Bayes theorem with the help of an example. Let us understand that we are given two different values. First statement states that 80% of spam mail contains word by. That is, whatever the spam mails are there, in that spam mails, 80% mails are having word by. And second statement states that 5% of non-spam mails contains a word by. So we are given only two type of information, that if byword is there, 80% of spam mails already contains byword and 5% of non-spam mails contains byword. So if I tell you, if there is a new mail which is of type or considers the word by, what is more likely to be? Whether this mail which contains the word by is spam mail or it is not spam mail. Is it enough information to deduce a particular hypothesis? So let us consider that hypothesis 1 says that this new incoming mail is of type spam. And hypothesis 2 says that this incoming mail is of type not spam. And email E, which contains byword, is considered as an evidences. Now we have two different types of probabilities. First probability that says that we know that mail is of spam type, but in that spam only 80% mails are of containing byword. So probability of an evidence that mail contains byword, given that hypothesis 1 is already true, that is, it is a spam mail. So P of E given H1 is read as probability mail contains byword given that that mail is already spam is equals to 0.8, which is nothing but equivalent to 80%. So probability of E being H2 is read as probability email which contains byword but it is not spam. Just a second. So this is not spam. Okay, so probability that mail contains byword, that is E, given that H2 is already true, that is mail is not spam, that is 0.05 because 5% mail doesn't not spam but contains byword. Now we have to find out if any mail comes in which contains byword, that is E evidence is there. What is probability? It will be of supporting hypothesis H1. That is P of H1 given E. Probability mail is already spam given that mail contains byword. That is needed to be find out. Also, we will find out what is probability that this mail is of not spam type. Whatever the probability is the highest will be supporting that hypothesis. One thing you should consider this as here I must write not. We will calculate each of these and whatever the likelihood or whatever the value out of these two is greatest will be supporting hypothesis or will be the correct hypothesis. It can be either H1 or it can be H2. So here whatever component that we have got, probability of E given H, probability of mail containing hypothesis H is already supported, is called as likelihood. So here we are having two different likelihood, but we do not have enough of information. What is left is the third type of information. We must know how many mails are already spam and how many mails are not spam. So it is said that only 1% mails are of spam type. So here we are provided with third type of information that only 1% of mails are of spam type. So we have probability of H1, that is probability of supporting hypothesis 1 that mail is spam is 0.01. Now whatever this value we have calculated, this is called as background or prior information, prior probability or simply prior, which is denoted by P of H. If there are multiple hypotheses, we would have P of H1, P of H2 and so on. But P of H is called as prior or prior hypothesis, prior probability. Now, if we have P of H1, what is P of H2? What is probability of supporting another hypothesis? So probability of H2 is 1 minus P of H1, probability of non-spam mails, that it is equal to 0.99. So if this is my complete mail space, we have to find out probability of evidences, that is what are the total number of mails which actually contains byword. Now remember, mail can be of two types. Let me write down this way. Now in order to calculate this by, let us understand this way. Mail can be of two types. It can be of spam type and it can be of not spam type. Within spam, there can be a byword or there cannot be byword. Within non-spam also, there can be a byword and there can be no byword. So spam and not spam is our hypothesis and by and not by is our evidence E. If I want to calculate E, I want to calculate those mails which are having word by and spam and those mail which are containing by and not spam. So summation of this value plus this value is total value which mails contains byword. So probability of event E which contains mail with byword is P of E. So marginal value which is called as P of E. So let us calculate this B of E. So spam mails are of 10 type 1%, that is 0.01 and not spam type of 0.99. Now spam mails which contains byword is 80%, that is 0.8. So remaining will be 0.2. Not spam mails which contains byword is that is 0.05. So remaining will be of 0.95 types. So probability of E would be 0.01 into zero point 0.8 plus 0.99 plus into 0.05. Probability of spam 0.01 into zero point 0.8 plus 0.99 into 0.05, and this value is turns out to be 0.0575. I leave these calculations up to you. Now let us move ahead and calculate something called as posterior priority. That is, posterior is given as probability of hypothesis given that evidence is true. So we have two different types of posterior. First one is H1 given E and second one is H2 given E. Now let us first calculate probability of H1 given E. Now using Bayes theorem, probability of H1 given E is given as probability of E given H1 into probability of H1 divided by probability of E. So these values can be substituted directly. Probability of E given H1 is zero point 0.8. So I would write it as 0.8 into probability of H1. Probability of H1 is 0.01. So this would be 0.01 divided by probability of E that we have just calculated is 0.0575. So this will be 0.0575. This calculation I am leaving up to you. Directly I am substituting value which is of type 0.14, which is equal to 14%. Likewise, I have to calculate for probability, posterior probability of H2 given E. So this H2 given E is calculated using Bayes rule is probability of evidence given H2 into probability of H2 divided by probability of E. And this can be calculated as substituting values from a given reductions, that is E given H2 is 0.05, so this will be 0.05. Probability of H2 that we have drawn is 0.009. 0.99 divided by probability of E, which is equal to 0.0575. Calculations again left to you, and we will calculate, and we have found out that this value will be of 86%. Now as you can see, we are having support of 40% to our hypothesis H1 and we have 86% support to hypothesis H2. So what is our final hypothesis of male? So that is calculated as maximum A posterior. Maximum A posterior is nothing but map. For hypothesis it is given as H map. So H1 given E is 14% and H2 given E is 86%. So H map is given as argmax of all hypotheses in a hypothesis space and their probability P given H of E. So argmax of probability of H1 given E and probability of H2 given E is would be argmax of 14,86. So this is for H1 and this is for H2. So maximum argument is 86. So supporting hypothesis will be H2. So whatever mail which comes in with keyword by, it is more likely to be not spam. That is the conclusion of Bayes theorem. One exercise is given to you. This exercise states that there is a tumor which can be of malignant type or it can be benign, that is non-malignant type. That is, it can be harmful or it cannot be harmful. Only 5% of population has malignant tumor. So this value is your prior information, that is. Now in laboratory test reports detect that malignancy is present with 98% accuracy. That means we know that it is a malignant tumor, that evidence is already given. Test result is positive with 98%, that is equal to 0.98. Moving further, it also states that lab report shows malignancy is not present correctly. That means negative reports are correctly detected by test in 97% of cases. If lab report is showing malignancy is present, what is the probability? It will be a tumor of malignant type only. So in order to solve this particular case, let us assume this is the population. And out of this population, only 0.5% of this population gets malignant tumor. And out of this malignant 0.5 population, positive reports are correctly detected with 98% accuracy. So these are red part is your positive report. So it is 98% over the left hand side. So negative reports are of already 2%. Over the right hand side, negative reports are correctly identified 97% of time. So remaining populations, they are already negative, they do not have malignant tumor and their negative report is correctly identified 97% of times. That means how many positive results will be there? There will be 3% of cases where there is a positive result. If I would like to draw in another way, a tumor can be of two types. It can be of malignant type or it can be of non-malignant type. Only 0.5% chances is there that it tumor will be of malignant type. So total 99.5% chances there it will be of non-malignant type. If it is malignant type and its lab report is positive, that is accuracy is 98%. So what are the chances that lab report is negative? There are only 2% of chances. Similarly here, if it is non-malignant type and it detects malignancy is not present correctly, that means lab report shows negative result is having accuracy or 97%. So lab report being positive is only 3% of probability is there. Now we have this, okay. Now this is my hypothesis 1, this is hypothesis 2 and this is my evidence E. I have to first calculate what is this probability, this particular final value. So this final value is composed of these two values and this final value is composed of this value. So H1 is nothing but malignant tumor and blue part is non-malignant tumor. And out of this, we have only positive results with malignant tumor is 98%. So negative results in non-malignant tumor is 97%. So negative result in malignant tumor, that is this small part is 2% and this is 2% because this is 98%. And if this is 97%, this will be of 3%. So positive results and non-malignant tumors are of 3%. We have these values, okay? Now, question is given that if lab report is showing malignancy, that means in a test, we know it is a positive result. What is probability that it is of malignant type and what is probability it is of non-malignant type? So this is malignant tumor and this is non-malignant tumor, NM. Okay, we will calculate both of each of these and whatever the value is maximum will be our supporting hypothesis. So final value is nothing but H map. H map is given as argmax of H given H, probability of H given positive result. Now there are two different hypotheses. Hypothesis can be malignant tumor or it can be non-malignant tumor supporting positive lab test reports. So this particular thing is substituted using Bayes theorem. So probability of malignant tumor supporting positive tumor is given as probability of positive tumor given malignant tumor into probability of malignant tumor divided by probability of positive results. So we will calculate similarly at this side, but this side our hypothesis is non-malignant tumor. So in each of these cases, as you can see, denominator side is same. So irrespective of what is this value, we are judging greater or lesser value based on denominator value. So at this stage, we can directly skip calculating probability of positive result. We will directly calculate argmax result based on denominator only. So probability of positive results being malignant, that is 0.98, and probability of malignant result is 0.005. Similarly, probability of non-malignant tumors and its positive result is 0.03 and 0.995. So the calculations I have left, that this left hand side calculation is for malignant tumor and right hand side calculation is for non-malignant tumor. And these values are found out. That means supporting hypothesis for malignant tumor is 49% and non-supporting non-malignant tumor is 2.95%. So out of these, this value is the greatest. So our maximum argument is that the hypothesis will support that even though lab report is showing malignancy is present, that it is non-malignant tumor. So this is our final answer. So this is all for today. In this video, we have tried to cover Bayes theorem with two different examples. Thank you everyone for watching this video. This is Munira Topia signing out.